So in some textbooks, depending on which editions and stuff you're looking at, people call this the standard form. I like to call it the vertex form because it gives you the vertex. All right, and we're going to take a look, and I have one of those programs today where we're going to compare what we did yesterday with just ax squared plus bx plus c, and we're going to compare it to our standard form equation. So first, let me give you what it looks like. Okay. So our standard form, also known as vertex form, is a times x minus h squared plus k. What's nice about this is all those things that we talked about yesterday, the vertex and the axis, okay, we can get that directly from this equation. So we have the line x equals h is the axis of symmetry. Now just be careful. Here we have negative h. So we're always taking the opposite sign when we're doing this, okay? Kind of like how in geometry, when you did translations, if you moved left or right, it was the opposite sign of what was, whatever you were doing. So if you moved it right 2 units, okay, it was x minus 2. If you moved it left 2 units, it would be x plus 2. Okay, so it's kind of opposite. So we have the line x equals h is the axis of symmetry. And the point h comma k is our vertex. So other thing I want you to notice is, like our other form, okay, I'll put it up here. Okay, notice it has this variable or this constant a, okay? And we treat a as we did before. Essentially, it's the same thing, okay? So when a is positive, it goes up. When a is negative, it goes down. If it's a large number, it becomes skinny. If it's a fraction, it becomes wide. Okay, so a here gets the same treatment. All right, so what I'd like you guys to do I'll give you a second if you need to copy that. And then we're going to go to our GeoGebra website. All right, so if you would please go to geogebra.org/classroom and enter this 8-digit code. All right. So what you have here is on the left, you have three different forms. We're not going to worry about the factored form yet. We'll get to that eventually. But what I'd like you to do is to click the box next to expanded form and vertex form. Who we waiting for? We're in. And Jack. All right, I'll come back to this if you need it. I just want to. Oh crap! Where did I put it? Okay, so here we have our expanded form. So with the expanded form, you can slide this around and see what happens to our graph, right? So with A, here I'm changing what A is. So what I want you to do is I want you to change the A of the expanded form and the A of the vertex form and try to get them to the same number and see what happens to the graph. Right? You can mess around with that.
We noticed that they're the same.
Right. Yeah. So as long as those A's are the same, right? If you're not doing anything else with it, if you're not, messing around with the vertex or the B or the C, then right, you get the same graph. It matches up. So down here in the vertex form now, okay, you're going to change where the vertex is. All right. So you click it over to the left, right? And you can see in here how it's represented, right? Because we have A times x minus h squared. So what I want you to try to do is pick, a vertex form. Actually, let's pick one together. Let's do h is positive 2 and k is negative 1. What I want you to do is I want you to try to mess around with the expanded form and see if you can get them to match up to the same equation. All right, so in the vertex form, you're setting a is 2, h is 2, and k is negative 1. And try to match that up with the expanded form and then see what you get as your equation for the expanded form. And while you're doing that, I'm going to take a look at you guys, what you're doing.
What do we do now?
Did you?
Yeah, like if you got it to match up, what do you do?
Did you got them to match up?
Yeah.
Yeah.
All right. So then, just wait a second and write down what you have for your expanded form.
Okay.
All right. So how many got it, or how many are close, they think? And I can look at what you guys are doing. Now, if we didn't have, so keep going if you know, if you're trying to figure it out. But if we didn't have a graph to look at, how do you think we could?
Don't look at mine. So I'm still doing it.
I'm just checking. Oh yeah, I could hide your guys' names so you don't know who's who. Okay, so you can mess around with this, but I just want to get moving along. So did somebody come up with?
Oh, I found it. Where they look the same.
Yeah. What was your new equation? What was your standard form or your?
The standard form is y equals 2.2x squared minus 9x plus 8.
Okay, and then that matched up with your other one.
Yeah.
And it was directly on top.
I wouldn't say directly. Oops. But
Okay.
kinda.
Okay, so actually, if you changed that top expanded form to a regular 2, that kind of changes things, right? So you're close. Okay.
Wait, Mr. Murray.
What's up?
A was supposed to be 2 or
Yes.
1?
2.
Okay. I made a mistake then.
Okay. Oh, but you got it as 1. Okay, good. Good job. So what's one way you think we could get from this form to another form without looking at the graph? What could I do to get this into the form we talked about yesterday?
Mr. Murray, I have a question about the graph.
What's up?
So if A, B, and C, like, they're equal to A, H, and K, right?
Okay, so the A's are equal, but the B and the C and the H and the K, I mean, they have a relationship, but they're not going to be equal to each other.
Okay.
Okay. There might be a case where it does kind of match up, but it's not necessarily always true. Okay, so one thing that we can do, right? So if we're given, I'm going to come back here. Get rid of this. Okay, so if we have this vertex form here, okay, one thing we can do is we can expand this, right? So I can have 2 times x minus 2 times x minus 2 minus 1, all right? Then here I can FOIL. So this is going to get me 2 times x squared minus 4x plus 4 minus 1. And then we just simplify it. So I distribute this 2. Right, and then we just combine like terms at the end. So, oh wait, I did that wrong. This is 8. Okay, so you can come up with the second one. So so let's take a look. Let's go back here. And of course, it's not working. So, right, so our first form, we had the 2x minus, okay, good. And up here, all right, this was close, but I'm going to change it. So I'm going to have the 2x, and then we said minus 8x, and then our c was 7. And look at that, they match up. All right, so what I want you to do tonight is mess around with this and come up with your own vertex form, and then try to match it up with what they call expanded form here. All right, and then so just write that down and we'll talk about it tomorrow. Tomorrow, what we're going to do is we're going to learn how to go from expanded form into our vertex form. All right, so you don't, I mean, you have homework tonight, but it's not necessarily like homework. You're just playing around with this graph. If you want to, instead of just writing it down, you can capture your screen and you can save it that way, okay? Or just write down 2 equations that equal. All right, so again, what you're going to do is you're going to come up with your own vertex form. If you want to keep A1 just for simplicity, and then just pick a random h and k, and then try to match it up with your expanded form. All right, so just remember that your a's have to be equal, and then you're messing around with your b's and your c's and your h's and your k's. All right, any questions? And if you'd like, you can maybe mess, if you have some time, you can mess around with the factored form and see if you can get that to match up. But like I said, we're going to talk about that a little later.